So all things stay the same is what we just did. We're just dealing with different orientations. So we need a let X be statement, which we've done before. We need a concluding statement, which is those three dots, right? They're there for. We round to one decimal place, which we did in the last couple examples. And then we include our units of measure. So in order, the example we have is in order for Annika to determine the width of a creek, she measures the distances on one side of the creek and illustrates them below. Okay, calculate the width of the creek. You're probably looking at this going, oh my goodness, I don't really know what's going on. So I'll try and outline it a little better. So this right here is the creek, okay? So that is the creek, all right? And her job is she wants to determine the distances or the width based on a similar triangle outside of it. So this would be the width of that creek, okay? Which is exactly D to E, right? D to E, we can see that's the width of the creek. So she uses a similar triangle to help her with that scenario or this illustration. So you'll see that A to C is equal to 3 meters and A to B being equal to 2 meters. Now, the only angle of reference we have, remember in the last ones we had little circles and check marks? We don't have those this time. So our angle of reference is just this box here, which means what? A 90-degree angle. So that's our only reference point. So we can also figure out where our hypotenuse is, which we've figured that out before. But the peak of it would be D, which we can kind of conclude is the same as B. And we can see now that C is shared between both triangles. So when we figure out our ratio, we're going to have to use the small triangle to figure out the big one. So in this case, I'm going to go 3 over 2, okay, is then equal to 12 over x, which is what I forgot to write, which is let x be the width of the creek. So I skipped that step, but I went back and did it. So let x be the width of the creek, and then we set up our ratio based on that, okay? These ones are a little harder. You need to kind of do a little more thinking, but once we set up that ratio, we know exactly what to do, right? So our step, what do we need to do? What's it called? Cross multiplication. So it would then become 3 times x equals 12 times 2. 3x would then be equal to 24. How do we get x by itself? Divide both sides by 3. Then x would be equal to 8, exactly. Okay? Ooh. Technical difficulties. So x would be then equal 8. And what's our unit we're using? Meters. So there, then we'd write our concluding. Therefore, the width of the creek is 8 meters. Fair enough, right? So again, much like the last examples, once you get your ratios